In this part of 6.3, we're going to look at finding the present value of investments. So that means the current value of the investment. So we're looking at, for this first scenario, a one-time lump sum. So what's the present value of a one-time lump sum for an interest earning account? So if we look at our formula, it looks very similar to the PERT formula. So if you remember in the previous section, this formula here. So the difference is the A and the P are switched, and now we have a negative. And the reason for that is because you're trying to solve for P. So that means you're dividing by e to the RT. So if I'm dividing by e to the RT, really what happens is you can rewrite this with a negative exponent. So you can see how this is pretty much the same thing as what's over there because those would cancel. So that's where this formula comes from. You're basically just solving for P. So you're solving for the principal, you're solving for that initial value so that you can find, well, what's the initial or the present value so that you get this future amount. So A represents the future amount. So let's go ahead and look at this example. So it says how much money must be invested now. So since we're trying to figure out how much money is invested now, we're trying to find the present value. As soon as I read that. And it also indicates it's a one-time lump sum investment because it's saying how much now. And then since there's an interest, that indicates, again, that I'm going to be using that formula from up top. So I'm going to be using the PERT formula kind of in reverse, already solved for the principal. So this is a situation where it's a one-time with interest. So no integrals because we're talking about a one-time investment. So that means I'm going to be using my formula here. So my present value or my principal is equal to the amount times e to the negative RT. If you didn't want to use this formula, you could use the PERT formula and then solve it like I did up above. So that would work. So, and it says that we're starting with we want $15,000. So how much will be invested now with an 8% interest so that $15,000 will be available in 10 years. So my time frame is 10, my interest is 8%, and then we want to get 15,000. So it's going to be P equals 15,000, that's my amount, times E. My rate here is going to be 0 or 0.08. So make sure you have that negative there. And then my time frame is 10 years. And then all we're doing is we'll put it in our calculator. And like I said, you could use that PERT formula. It would just mean you're dividing by e to the 0.08 times 10 power. But there wouldn't be a negative because you're dividing by it. So just keep that in mind. Either these are equivalent ways of solving. So when I do that, I end up with $6,739.93. So that tells me if I wanted to get $15,000 in 10 years, I would have to start with this amount earning an 8% interest. And then that would get me the 15,000 in 10 years. So that's what it means. And this is good to know because if you're trying to save money and you have, the interest and it's compounding continuously and you know how much you want to have in a certain time period, this will tell you how much you need to start with. So that's kind of how this can be helpful. And then lastly in this section is we'll now applying this with integrals. So how can this help us with integrals? So there's this formula for present value of a continuous income stream. So what happens if you have a continuous money flow, there's interest, and you want to know what is the present value of the account or what is the lump sum that it would take now to equal whatever the future value is you want in so many years. So that's kind of what it's going to tell us. So this situation is going to be for continuous money flow with interest. So anytime, hopefully with all these little notes here, anytime that you're seeing continuous, it means integral. And then interest just indicates that you're going to have that E being raised to the RT. And otherwise, if it just says a one-time, well, then it's really not a calculus problem. It's really just an algebra problem with that PERT formula. So just kind of keep that in mind. So let's look at this last problem here where we're going to have multiple parts. So it's going to kind of recap everything that you've seen in this section. So a company can buy a machine that is expected to increase the company's net income by $10,000 each year. So that means continuous money flow. So that means integration for the 5-year life of the machine. So it looks like we're looking at a 5-year time period. The company is also, so this should be a period here. The company also estimates that for the next 5 years, so again, 5-year time period, that the money they invest from this continuous, so if you didn't catch it here, well, here they're telling you it's a continuous stream of money, so integrals. We have interest, and then we want to find and interpret these different things. So basically, there's different situations. The company can get $10,000 a year for just the machine, but if they invest that money, so that's key here, then they can earn 7%. So then we're looking at a situation, well, now we have continuous money flow with interest versus just continuous money flow without interest. So there's two scenarios here. So if we look at the first part, it says find the total amount of money produced only by the machine. So that means no interest. So they didn't invest it over its 5-year life. So this situation, part A, is going to be continuous money flow without interest. And then for these other ones, well, they kind of tell you right in the situation, the future value and the present value of the income stream. So that means this situation here, if they invest the money. So for these other two parts, these are both continuous problems. So we're just going to use our formulas. Continuous money flow problems with interest, because we're talking about an income stream. So how much money are they going to earn if they have a 7% interest? So that's the second scenario. So let's go ahead and set these up. So for the first one, this is going back to the very beginning of the section. So we have a continuous without interest. So since it's continuous, it is an integral. So my amount is going to equal my integral from my 0 to the time period. So 0 to t of f of t times dt. So that means the amount is going to be from 0 to 5. My time period's 5. The amount each year from the machine itself without putting it into an account earning interest is $10,000. And then you just solve this. So again, here's another situation where we don't really have to integrate this because I'll say it at the end. So let's look at the integral. So $10,000 times t would be the integral of 10,000. And then I have to plug in 0 and 5. So it's going to be 10,000 times 5 minus 10,000 times 0. So we end up with 50,000. So you could probably see why you don't necessarily have to integrate this, because if I know I'm getting $10,000 for 5 years, well, 10,000 times 5 is going to be 50,000. So again, you didn't really have to integrate this one, but there will be times where you will want the integral. So in this case, we're just going to use the integral because it'll help you with future problems that might not be just a constant function. So there's your first part. The second part is asking for the future value. So the future value formula goes from 0 to t, and now it's going to be, there's interest. So it's going to be your constant or your function times e to the rt with respect to t. So then we're going to plug everything in. So we're still looking at 5-year time period. We have $10,000 being added, but now we have this interest. So my interest was 7%. So that tells me the rate is going to be 0.07. And then t stays because that'll get replaced later with our constants. And then we integrate this. So we have 10,000 e to the 0.07t, because remember when you integrate e, it stays the same, but then you got to divide by that number in front. And this is going to get integrated from 0 to 5. So we go ahead, you could divide that out, but it's not going to come out nice, so I'm just going to leave it as a fraction for the sake of entering it into the calculator. So I have, because you don't want to round here, so I would just leave it as a fraction if it doesn't come out nice. And then what you can do is you can just kind of keep that constant out in front, so you don't have to plug it in as many times since it's not as nice. So I plug in 5, and then I can plug in 0. So then what happens is this is going to become 1. Type that in your calculator, -1, and then multiply it by this. And I end up with $59,866.79. So that would be the future value if it went into an interest earning account. So basically part A shows you $50,000 without interest. Part B is showing you, okay, well, you get $59,000 if it went into an account earning 7% interest. So that's kind of how those two compare. And then the last part is your present value. So your present value formula. So we have the integral from 0 to t. Remember, it looks pretty much the same thing as future value, but the difference is you have to have that negative. So that negative RT. And then we go ahead and we plug in. So it's going to look very similar, but we're going to have a negative. So that negative is going to be huge because that's what's doing that. It's basically undoing the formula. So that's how we're getting this to work. So the future or present value is going to be from 0 to 5. Again, time period's the same. 10,000s, that continuous money flow. E to the negative rate, so 0.07. So again, like I said, it's going to look very much the same. So you have to be very careful here that you have that negative because it looks so similar. And then when you go to do your integral, again, it's going to look very similar. Except for now we're dividing by a negative. And then I would do the same thing where I just keep this number out in front. And then we're just plugging in. Just be careful when you're plugging in, again, that you have that negative. So it's going to end up being this -1, because this will go to 1, times the 10,000 over negative 0.07. And when you do that, you end up with $42,187.42. So what this means, let me get that 42 there. So what this means is the present value of the account is worth $42,187.42. So in other words, what that means is this is the amount of the lump sum that would have to be deposited now to have the $59,000 later. So instead of doing the $10,000 continuously for the next 5 years, this is what you could put into the account one time lump sum with an 8% or not 8%, 7% interest, and it would then equal the 59,000. So that's what present value is telling you, is what would the lump sum have to be to give you that future value that you wanted. So that's what it means. So those are all your different formulas. Remember, if you see continuous, that means integral. If you don't see continuous, it means you're going to be using that PERT formula. And with the exception of if there's interest, then it's going to be using that PERT combination with integral if it's a continuous problem, versus if there's no interest, then you're looking at something like Part A here. Otherwise, just pay attention to the wording, pay attention to the detail, especially with those negatives in the present value formulas.